Oh shit. Whew. Huh? Top tire's over.
So this is not going to be a dirt bike video. This will be my story of how I found out about getting cancer and what I have. So if you're not interested in that, you can stop the video now. So anyhow, just have been asked about this. This is going to be my summary of everything. So how it started out was in 2014. I went to the gym one day, and I noticed that I was out of breath. I went on the elliptical, but I usually could do high intensity for 20 minutes, 40 minutes or so. I could only do level 1 for 5 minutes, and my legs were killing me, and I was completely out of breath. On the weights, I mean, just one set would make me completely out of breath. And it's the first time I had ever felt like I was going to throw up what I just ate after going to the gym. I never felt that before. I always hear people saying, oh, you work out so hard you feel you're going to throw up. Or people do throw up. I've never thrown up and never even felt like it remotely. And I barely did my first set and I felt like it. So that's when I first noticed it. And I would say that's probably summer of 2014. And then as you can see in the first video, that started translating into dirt bike riding. When I would go up a hill or do some more technical stuff, I would get tired out so quickly. And before, I could go on all day. I could do this stuff for several hours, come back, gas up, go back out again. And I was wondering how other people couldn't do it, because a lot of people would get tired out. Like, I never got tired out. And here I am getting tired out immediately on doing one thing. So anyhow, people would say, oh, it's deconditioning. And so, you know, I kept going at it, and it just never got any better. So, in November 2015, I finally scheduled an appointment with my primary care doctor just to go over this and see what's wrong. And that appointment happened in December. And the first thing they said, you know, after I told them everything, was it's probably deconditioning. Okay, so anyhow, they did some standard testing, really, just a renal panel for the most part, and found out that I was in stage 4 kidney disease. So I was in stage 4 chronic kidney disease, which has a range of your effective GFR of basically 15 to 30, I believe it is. Under 15, you're in 5. So my GFR right now is somewhere between 17 and 21. It kind of bounces around there. But what your GFR should be is actually, it should be kind of be greater than 100, probably around 117. But the tests typically only measure, it will say it's greater than or equal to 60. That's typically what the tests measure. So anyhow, whenever I found out that I was in this, I didn't understand what they didn't really actually come out and tell me this. So I eventually ended up going to the urgent care because they had me do some tests, and I missed my nephrologist, the kidney doctor, appointment. And they go and schedule me out like months later. And so I'm just going to go to the ER and get a second opinion, because I don't understand how this relates to my out of breath problem. And typically, just so you know, you can have a GFR that's low, and when you take some medications or something like that, but when you stop whatever is affecting the GFR, it usually bounces back up. So at the time, wasn't sure whether this would bounce up or not, because it didn't make any sense that I was in that low. So, but after I was a week in the hospital, it had not rebounded. So I started on steroids and stuff like that. Did a kidney biopsy and didn't find anything. So they also sent it off for electron microscopy, and that came back as white powdery deposits, granular deposits. And so the diagnosis was monoclonal monoclonal gammopathy. So to understand what this actually means, you need to understand a little bit about how the immune system works. So, because this is actually a bunch of diseases, so a bunch of cancers and precancerous conditions. So you have B cells in your bone marrow that produce antibodies, or they call them immunoglobulins, but antibodies. And so whenever you have you interact with some kind of bacteria. Oh, by the way, I was supposed to say this there. I am not a doctor. I am not a doctor. And I have zero medical background. Okay, just to clear that, so don't take this as advice. So anyhow, so you have these antibodies. Whenever the immune system runs into some bacteria or whatever, so some antigen, foreign invader into your body, creates antibodies against it and destroys it. The antibody looks like this. It just divide it up here. Something like that. Okay, so this is an antibody. It consists of a pair of heavy chains and a pair of light chains. They're the same type of heavy chain, same type of light chain combined together for 10 different types. And so the heavy chains would be IgM, IgG, IgA, IgD, and IG. I want to say E. I don't remember what the last one is. There's 5 of them. And actually other animals have different ones. There's also an IgW in sharks. Light chains, we have lambdas and we have kappa. Other animals actually have epsilon. So these have a structure. This up here is known as the hypervariable region. This is the variable component. And down here, the bottom is the constant domain in the variable region. Within the variable region, these loops that you see off of here are called complementary determining regions, or CDRs, 1 through 3. And those are the antigen binding sites. And so the constant domain is the same for every type of light chain or heavy chain. And the purpose of the constant domain is whenever you bind to some type of antigen, it signals Fc receptors, and it basically works with the immune system to figure out how to deal with it, what type of attack or what type of method to use to dispose of, whether something comes and attacks it or they bind to it and prevent it from reproducing or whatever. The variable domain is variable. It's a set of proteins that the immune system has determined will bind to that antigen, and it creates these variable. And the hypervariable region, or the CDRs, is the site where that happens. So this is what a whole antibody or immunoglobulin looks like. Now, your body also creates what are known as free unbounded light chains, which aren't bounded to anything. Now, typical B cells will produce all 5 of these, and they'll produce 2 of these, make whole antigens. So mono means 1. Clonal. So this means you have a clonal population that produces 1 type. Typically 1 type, but they can produce more, but typically it's 1 type. In my case, it's kappa. So I have a monoclonal population of B cells, or what they call them actually myeloma cells at that point, of kappa. So I have an overproduction of kappa. And this caused, this overproduction of kappa caused deposition in my kidneys. And so that's what happened. Now when you look at the bone marrow, you figure out what percentage of the bone marrow population is actually monoclonal. And in my case it was 9%. So if you're less than 10%, it's considered something called MGUS, or LC, light chain MGUS, which just means monoclonal gammopathy of unspecified significance. Usually is a benign condition and doesn't do anything. In my case though, since you see deposition in the kidneys, it now becomes something else. In my case it becomes light chain deposition disease. So now light chain deposition disease, there's also light chain myeloma, multiple myeloma. So multiple myeloma usually has an M spike. M spike means monoclonal protein spike, which usually means one of these heavy chains is spiked in more concentration. Usually, I believe A or G is the typical. And those is a bone cancer. And you would definitely have more than 9%. If you have greater than 10%, it's myeloma. So I have less than 9%, which typically means it's benign. However, in my case, it is not benign. It ends up being light chain deposition disease. Now what happens in these proteins is that you have something called a complementary DNA, which is just a chain of DNA that tells you how to build these light chains. These light chains are nothing but proteins, and each DNA tells you which protein to use. What ends up happening is there's substitutions, deletions, and insertions within these light chain structures that make them abnormal. And everyone's different. So, however would happen for someone else whenever they have these monoclonal populations is not going to be the same sequence for another person that would have the same problem. And light chains can deposit in the kidneys and the liver and the lungs and the brain and the heart, but those are more rare. The kidneys is the main one, it's the most common. Now there is another one called amyloid. Now light chain deposition disease is non-amyloid, but you can also have something called amyloid. And amyloid just means that the protein, whatever protein substitutions and things that they have, cannot fold. Folding means they come like this, I guess. This is a structural change. But if they can't fold, they become amyloid, or they can't fold all the way, amyloid, and they're considered insoluble. Once they start combining with other amyloid proteins, and once they get 4 or more, they combine what's called an amyloid fibril. And that is like a plaque. And basically it starts depositing in different organs. It's very bad. Depending on, for light chains, it's primary AL or systematic AL, amyloid light chains. But amyloid is actually found in 20-some different diseases that are in the body, depending on which type of protein is malformed. For example, Alzheimer's is an amyloid style disease. So I believe diabetes is too. So anyhow, whatever changes have been made, whatever's being generated ends up depositing in the kidneys for me, and that's what happened. So whenever I start out, your population of the maximum is supposed to be like 1.94 kappa free in the bloodstream, and I had 18. And again, I had 9% clonal cells. So there's no stages to this because it has nothing to do with the cancer itself. It has to do with what organs are being destroyed and when those organs are completely gone. So for me, I'm in stage 4 chronic kidney disease. So, and again, even if you destroy this population or it comes back, you have no way of knowing whether or not you would have light chain deposition disease again, or if it's benign, unless you actually see the kidneys being destroyed, because there's no way to test what these light chain structures look like and then predict what they're going to do. You just have no idea. If they would only have seen this, that I had the 9% clonal, they wouldn't have treated it, because they're considering MGUS, or light chain MGUS, benign condition. It's a pre-malignant cancerous condition that can eventually turn into myeloma. However, since I'm now having deposition in the kidneys and the kidneys are destroyed, then they have to change the diagnosis to MGUS, or light chain MGUS, with light chain deposition. So I went on 4 cycles of chemo. I took Velcade, bortezomib, I think is the generic for that. That was it's a type of chemo that basically prevents proteins from breaking down. And originally it wasn't a cancer drug. It was originally being researched to prevent muscle breakdown. But they found out, they're not exactly sure how it works, but they found out that it works in myeloma type diseases. So I was on the Velcade. I took that on Mondays. On Tuesdays I had Cytoxan, another chemo. And then I had a steroid called dextromethasone. And then this was what I took. So after 4 cycles, 18 went down to 5.8 of kappa in the blood. And again, you don't know what's normal and abnormal. 9% went down to 5%. And they call this a partial remission because I have achieved, I have reduced the original disease down. So it's considered a partial remission. So, and I'll throw up some things about this here. I'll throw up the main thing where I found about this thing here. There's a study. Typically, if you look at the DNA, there's 3 letters that make up, for example, a protein. And if you change one of those letters, you typically end up with the same protein. So a lot of mutations don't even matter. They're benign because they end up with the same protein. But anyhow, in this case here, this is kind of a rundown of what happened. So you have basically cells in the bone marrow that are supposed to produce antibodies, but they only produce part of an antibody, the light chain part, in my case kappa, which kappa is associated with better outcome than lambda. So I have a few things on my side is that kappa has better outcome than lambda. It's not amyloid. Amyloid's worse off. I have a small population. I don't have any other diseases, so a lot of people who have light chain deposition sometimes have myeloma with it, or they have diabetes, or they're older. So now what I have, light chain deposition disease, is extremely rare. There's also a heavy chain deposition, which is even more rare, because I think only 1 or 2 people have ever been diagnosed with heavy chain deposition. But yeah, as far as light chain deposition, there's maybe 10 people right now that have it besides me. So it's very, very rare. So my next step, now that I've done that, my next step is a stem cell transplant, and I'm going to make a separate video on that. So if anyone's interested, you can comment down below. Let me know if you're actually interested in it, but I'll go over it. Let me show you something here. I have what's known as a port that was put in. So anyhow, I can go over that in a separate video. And the reason I would do that in case someone actually is going to go through that process and are searching for a stem cell transplant, they can come across that video and maybe get my perspective on what I went through at least. So I'm starting to go through it now. I just started. So anyhow, that's what I have essentially. For the most part, the chemo, these didn't really affect me that much. The chemo that I had, didn't really affect me that much at all. So, for the most part, I mean, it seemed like the symptoms were like this. I had none the first cycle. Yeah. So I had like none the first cycle, and then it started to go up like that. The second cycle I had a peak, and it started to come back down again. Some symptoms stayed up though, but it's kind of like that. That was kind of how my symptoms were. You know, I had some early on initial, somewhat no appetite for a couple of days here and there, but otherwise it was fine. I had a little bit of nausea and took Zofran and went away. The main side effects I had was from the Cytoxin. After like the second cycle or so, I started to feel like, just with the day I took it, I would feel like my throat was numb, my tongue was numb, like I swallowed a whole bunch of Mylanta, and then my hands would get like that, and my feet, and sometimes my back. But it only lasted a day, and it would go away. So that was really the major side effect I had. I didn't have anything else. And for the Velcade, I really didn't have any side effects, because I had it on Mondays. I felt nothing. Nothing came. It was only when I took the Cytoxin that I started getting it. And one day when I switched Velcade to the same day as Cytoxin, I still got it exactly when I took the Cytoxin, because I took the Cytoxin later in the day. I got it like 2 hours after taking the Cytoxin. So I definitely figured out, I took the Dex and the Velcade in the morning. So definitely figured out that that was the link. So anyhow, I'll link some, for anyone who's interested, some things in the description about the stuff, about the definition of these chains, the study that I found that talked about why these might deposit, why they wouldn't. So